Today we're going to discuss the installation of the Focus Applied Technologies Power Stretcher. This is a piggyback fuel injection system used on pretty much anything with fuel injection. And today we're going to be installing it on this motorcycle here. This is a 150cc motorcycle, a Yamaha Y15. First thing we want to do is identify where is the stock ECU. In this vehicle, it's under the front nacelle, and you can see this is the ECU over here. What we'll do is we disconnect the wiring harness, and you can tell it's got a lot of pins on it. Generally, what we do is our fuel injection system comes as a wiring harness that goes between the ECU and the wiring harness of the vehicle. In this case, we've left it open so that we can see the lights on it when we start, when we power it up. So we'll just connect it here, connect it firmly between the ECU and the wiring harness. This way, if for some reason you want to disconnect it, you sell the motorcycle or something like that, you can simply unplug it. Okay, now let's confirm that we've got power. Okay, we can see that there's blinking lights, so it's been powered on. Now we're basically ready to store it in here. Probably we'll zip tie it in place. The only other thing we need to be concerned with is this version uses a cable for communication. We'll keep this cable out here so that we can connect the computer to it for tuning. All right, we have connected our power stretcher to the computer via a serial COM cable, in this case a USB serial COM cable. And now we just want to key it on and do some simple calibrations. Essentially, we start with the throttle. So we can open and close our throttle. The easiest way to calibrate it is with your TPS auto calibration. So we click on TPS auto cal, and it shows up that it's in calibration mode. We go wide open throttle, and then idle, and the auto cal is clear. Okay, now it's re-bracketed the voltage for the throttle from basically 0% to 100%. As I open the throttle wider and wider, it'll go up to 100%, and then all the way back down to about 0%. Okay, now that's the throttle calibration, and we're done with that. Now you'll see down here, this is our fuel stretch. Each bin represents a different throttle. Right now I'm at idle, so I'm using this lower bin. And now I open up the throttle to about 5%. I'm using the fueling from this bin. Here's 20%. Now I'm up at 80% or 100%. So when I'm at 100% throttle, I'm going to use this bin here for my additional fueling. In this case, you can see it's at 105%. If I'm at, say, 20%, I'm using this bin here and it's 104. If you want to increase that for drivability, you just click it up. If you want to decrease it, you can click it down. So I don't like 104, I want it 103. Okay, now it's set at 103. We'll adjust this based on drivability. You can also adjust it on the dynamometer if you're doing some road load testing, something like that. So we want to make sure that our stretch is on. If you click on this button, you can turn it on or off. If you have to go past an emissions test, you click it off. Then you don't have any stretch. If you are driving around on the road, you can click it on. The other thing we want to do is adjust our oxygen. So the oxygen is, the sensor is in the exhaust stack, and it tells you if you're running rich or lean. So the normal mode that we would use is called shift mode, and we set that up under the oxygen settings. So in our oxygen settings, it tells us that we want to follow this shift mode between these two numbers. So between 5 and 80%, we're going to follow the shift. And over here is the shift, so it's 110. That means we're going to bias rich by about 10%. Between 5 and 80% throttle, we will shift the oxygen signal slightly in order to bias about 10% rich. If we're below 5%, we follow the real oxygen signal. And if we're above 80%, it doesn't matter because the engine doesn't use the oxygen sensor. It goes wide open. So essentially, we use these parameters here in order to send a false or a synthetic oxygen signal back to the ECU to where it doesn't have oxygen sensor error codes show up or something like that. One other trick you can do is to adjust the switch voltage. Normally, the oxygen sensor switches from rich to lean at about 0.45 volts. In this case, we can bump it up. In this case, it's bumped up to about 0.6 volts. That means your actual sensor has to get a voltage of 0.6 or above before we report it as rich to the ECU. That again allows you to run a little bit richer, gives you better throttle response, lower temperatures, more torque, more power. Once your oxygen has been set up, and our throttle's been set up and we like our stretch, we can burn that. And now, of course, we want to test it out. So now we can see that it's running, and we'll see that when the oxygen sensor warms up and comes on, like now we're reading an oxygen signal, and it's going rich and lean, rich and lean. The synthetic signal and the real signal are supposed to be following each other until we open the throttle. I'm going to open the throttle now, and what you'll see is when they go lean, they'll both go lean together. When the real one goes rich, the synthetic one waits for a while and then it goes rich, and that's the shift, and it'll only happen above 5%. So I'll rev up. Now, you don't see the real one switching very much because it switches very fast. But the synthetic reported one is going rich and lean, and that's telling the ECU, oh no, you're really leaner than you actually are. Okay, we can verify that this is running properly. One of the things we can do is we can remove fuel. So let's confirm we're actually running the stretcher by removing some fuel. You can hear the engine slows down a lot because we're starting to run it lean. Now I'll add the fuel back in. You can hear it's running much better, and we'll put it back to where it's supposed to. Now it's running just right. So this is a test we can do. We decrease the fueling and it slows down. We increase it. If we increase it too far, it's running too rich and slows down some more. Now we'll decrease it back to normal, and now it's running just right. So we've got that tuned right. We're happy with it. We burn it. Now all we have to do is do the wide open throttle tuning on the dynamometer. All right, now we're going to do some dyno pulls. During the dyno pull, we're going to measure the air-fuel ratio using an air-fuel ratio meter that's stuck into the exhaust pipe. And of course, we're going to be measuring the power and torque using a dynamometer. Just now we ran the stock system and have those curves recorded. We'll run another curve here with the stretcher on. We'll be able to compare. And you'll see the difference in torque as well as air-fuel ratio. So it's going to get loud. We're going to look at a dyno pull now, zoomed in on the screen, and you'll be able to see we're going to do another run of torque and power. Air-fuel ratio is down here. Then we'll go over and compare to the stock curve we got from this bike just a moment ago. It's going to get a little bit loud. Okay, now let's go compare that to the curve that we got from the stock system earlier. So this is the run we did just now, and this was the stock system earlier. You can see on the stock system, the air-fuel ratio is much higher. So what we did with the stretchers, we added quite a bit of fuel. In this case, our air-fuel ratio is averaging about 12.5, which is right about where we want to be. What that did is pretty much across the board, it's increased our torque. So we're getting maybe a 5% boost in torque across the board, which is a boost in acceleration, but also drivability and a cooler engine. Now, if we want to tailor the air-fuel ratio as a function of RPM, we can do that. We can do that with the RPM factor on the stretcher, which allows us to increase or decrease the air-fuel ratio as a function of RPM. In this case, the air-fuel ratio is quite flat, so it doesn't need any adjusting. Okay, that's all. Now let's see how it runs on the road. All right, now we're outside looking at the hand-flown application. It's an Android application that can talk to it via Bluetooth. So if we fire it up, we'll be able to control it from this panel here. Fire it up. All right, so you can see we're reading the RPM and various different throttle voltages and things like that. We can also control the fueling from here. So if I want to remove fuel, you'll hear it slow down. So now it's slowed down because I've pulled a whole bunch of fuel out of it. I can add that back in. You can also run with several maps. So it's got a selection of 3 different maps tuned for the road or other various configurations. So you can select through your different maps, which will have a tuning for, you know, aggressive driving or city driving or whatever. We can also turn on and off our oxygen strategies from here. And when you're happy with it, basically you can burn that and you're ready to go. And that's it.